Okay, for today, we are doing a review because 21 days ago, which is crazy, but is when you learned how to do some of this stuff, and that's a long time. So I have a feeling that some of this has slipped, oozed out of your brain. Do you remember what that little symbol, I don't want to say its name, is called? It's a summation, it's what it is. It's a sigma. Okay, so we're going to write a little formula here and see if you understand what it means. Do you remember what that means? Whenever you see that symbol, you should think sum of, because you're going to add up a bunch of things. What do you think the first thing is in the list? 7 is correct, because you'd put the 1 in. Take this one first. You put it in, and you get 7. I'd like you to make a list of all 4 terms. It won't be that hard to do. It'll give you practice in making terms. Mr. H, are you done already? Your hand isn't moving. So either you're done. Okay, good. Thank you. So then what's the next one, Mr. H? And the third one? And the last one. By the end, were you just adding 2? Yeah, because you figured out that there was a pattern here, right? And that this little, every time you added another one, it just added another 2, right? Okay, so that's a way that you can list terms. And then, would I be done? No, a very common mistake on the test is kids write the 4 terms out. But the point of a sigma is that you're supposed to add them all up. Now, I know with only 4 things, it's really easy to add them. I like doing first and last, 20, 20, total of 40. You get what I'm saying there? But what if this had been a whole bunch of terms? Then you'd need a formula to add them up. Now, we're going to give you this formula, so I'll give it to you right now. Let's say it's, yep, I see some of you can see it on the board over there, unless you have it memorized, which would be awesome. That is the first one and the last one, and then you multiply by half of how many there are. Does that ring a bell? That formula will be given to you on the test. Don't stress yourself about memorizing it. By the way, though, on their formula, they use a 2a. Do you see where, if you were making this formula, you might have simplified it to 2a? The a plus the a would make 2a, wouldn't it? So don't feel like, but that's a totally different formula than you said. Well, it's the same thing. They're just going to add the a's together and call it 2a. Okay? All right, so then let's use that formula to do the same thing. We already know it adds up to 40, but can you use the formula to do it and make sure it works? Know what I mean? We know the answer is 40. Just use that formula. Put the numbers in the right spots. And by the way, is this a geometric or is this arithmetic? This is arithmetic because it has a common difference, a d. That other thing does not have a common difference. If you're multiplying by like 6 each time, it does not have a common difference. It would have a common what? Common ratio. Very good. All right, how many things were there? 4, so you put that in the n spot. What was a? It was the first number. What was a again? It was the first number again. And then d, well, that's the common difference. It's what you added every time, which was 2. And then n minus 1, what is n again? It was 4. Let's see if this actually worked. Three times 2 is 6. I was careful not to destroy the order of operations there. And this is 2 times, in the end, 20. Why did it work out that way? Because it's supposed to be the first plus the last, and then you add them all up. And then there would be 2 sets of those 2. That's why we do 2 times the 20, which makes 40. Okay, but the beauty of this is that it would work for much harder ones. Like we could have added those in our head. So let's just do one where you wouldn't have been able to add it up in your head. Like, for example, I'm going to give you a new one of these. All I'll rewrite that formula up here for you because, yeah, the first thing you're going to do is probably just figure out the first term. If you ever get stuck on these, just start writing out the first couple terms and you'll start realizing what's going on. Why the first couple terms? Because it'll help you see what the common difference is. You know, like if you just know one term, you can't see what they're growing by. So maybe try to figure out the first couple terms. But do you really want to write out all 40 terms? I hope not, unless you're really into mathematical pain. All right. So here's that formula one last time. N over 2a plus parentheses a. In fact, I'm just going to get you used to this. That'd be 2a. Okay, pause for a second while you figure out the sum of these 40 terms. Yeah, it's a fairly biggish number. You pause for a moment while you figure this one out. All right. So, in the back corner, tell me, what was the first term of this little set? How did you get that -1?
1 in prime.
All right. And then 2 minus 3 makes -1. Awesome. I suggested you find a couple. So, did you happen to find the next one? You are correct. And then from that, you're able to say, well, I can tell it's going up by how much? By 2. And so you could have seen that right there, but either way, it helps sometimes to find the first couple terms. Do you want to find all 40? Definitely not. All right, so then we're going to put in the 40 here, though, and then tell me what to do in the rest of it.
Just substitute it for 3.
Got it?
A or 1.
D is 2. Very good. All right. Be careful with my order of operations. Uh, 60, 78, 20 times 78, 76. Did I do that right? All right, awesome. And then 76 times 2 is 140, 152, and then add a 0. 1520. That's not money, sorry. 1520, no dollar sign. Raise your hand if you had 1520. Okay, awesome. Now that was the easier kind, arithmetic. Now let's do a geometric. All right, so imagine for a moment you had a geometric that started with 2 and then tripled to 6 and then tripled to 18, dot, dot, dot. I think you get the idea. We're not adding the same thing each time, right? This question I'm going to frame a little differently. Make me one of these for the first 5 terms. You should be able to make me a sigma. Now, I do want to remind you about a formula that would be handy, because you would have this formula sheet. And that formula goes like this. For a geometric, there's 2 formulas that you'd need. One's for finding each term. One's for adding up all the terms. Here's the one where it finds each term. A times R to the, can anybody finish it? N minus 1, very good. And the other one is where you add them all up. This one's tougher. It's a fraction. Does anybody remember this one? There's a 1 minus, you are correct. And there's an A in front, you're right. A times 1 minus R to the something, to the N. 1 minus R, you are correct. Very good, you guys put it together. Nice job. That was the worst high five ever. And now take those 2 formulas, and you should be able to do 2 things. You should be able to write me a sigma. Hint, one of those formulas is very handy. And I would always start with n equals 1. You could theoretically start with 0 or start with 5, but the logical thing to start with is 1. That way, if you want the first 5 terms, it's easy to figure out what goes there. Notice it says first 5 terms. Okay, so then the hard part here is this. The easy part is find the sum. You'll just stick the numbers in the formula, and it'll tell you the sum. All right, I'm going to pause for a second. See if we can get this one right. Okay, so I hope you had figured out this part, that this was the formula you wanted to put right there. How many of you figured that out? Okay, if you didn't figure that out, you need to figure it out. The test is not like forever from now, so we do need you to learn this stuff. So if you didn't process that, you better write yourself a good example right now. 2, why am I putting a 2 there? Because that's what A is. R is also known, it's 3. And then to the power of n minus 1, why am I leaving the n in there? So that this little guy can do its work. You got to be able to put in 1, and then 2, and then 3, and then 4, and then how many do we do? 5. So there's a 5 right there. Raise your hand if you had it right. And that's a little less than half of you. So that's something that obviously we could work on. So what did I really do? I just took this formula right here. I stuck in A, which we knew, and R, which we knew. No, because it said first 5 terms, so we knew that we wanted the first 5, so that's why that's a 5. All right. So then, how about the sum of those terms then? The sum of those terms, well, it'd be kind of handy to know a formula for that. Ooh, I do know a formula for that. It's right there. So A is 2. 1 minus, what's R? R is 3. 3 to the n. 3 to the 5th. All over 1 minus 3. Well, one part that's nice is this. 1 minus 3 is negative 2. Do you get that these 2's can cancel? Sweet. And then negative is going to come out when the top part comes out negative and the bottom part's negative, so they're just going to cancel. So then it just boils down to, I've been avoiding it this long, what the heck is 3 to the 5th? 240 what? All right. So then that's all over negative 1, and then I have negative 240, let me make sure I do this right, 2 all over negative 1, so it's 242. Raise your hand if you had 242. All right. Okay. Now, that was a bit of a stretch. I only got about half of you guys getting that right, which I understand. This is a tough one. Let's do one more like that. So I'm starting with 3 and then doubling. Make the sigma for me. We'll do the first 4 terms so that we don't have to have like too big of a power to figure out in your head. So make a sigma, and then what is the actual sum? Now pause for a minute while you try that. And since the formulas will be available, I'm going to give you these general formulas. Pausing again. Okay, let's see if this one went a little better. It's this formula that goes right here. Because this one is multiplying each time, which makes it geometric. So it starts with a 3, and then you times by 2 each time. That's called the common ratio, R. So this is 3 times 2 to the n minus 1. N equals 1. And up at the top, it's a 4. Raise your hand if you had that one right. Okay, awesome. Let's say that your friend has something different, and they're like, no, you're not right. How could you prove that you are right? Well, find the first couple terms. If you stick a 1 in, and it actually works, that's 2 to the 0, which makes this just 1 times 3, which is 3. And that's what we were supposed to get for the first one, right? And then, maybe try sticking in 2 and make sure it gives you the second term. I think you get the idea. All right. And then what is the actual sum? When I actually add these all up, I could do it by hand because it wouldn't be that hard. I just have to do 12 times 2 is 24 and then actually add them all together. And that would be the fast way in this case. But I hope you know how to use the formula. And it would be A, which is our starting term, which is 3, times 1 minus R to the n, but I know R. R is 2. 2 to the n, and I know n. And n is the first 4 terms, so it's a 4. All over 1 minus r, which I know, which is 2. And there we go. Final answer. 3 times 1 minus 16 is negative 15. over negative 1, 3 times 15, 45. Can anybody verify 45 for a final answer? Okay, awesome. Then now, you're back, baby. You now know everything that you knew before break, pretty much. Okay. So now, we're going to go back and talk about infinite because we're going to do an infinite set of cuts on a piece of paper just to kind of demo this. And is it really going to be infinite? Of course not. One thing to clarify, we are not cutting out pieces. So we're not making one of these where you actually cut out little chunks. That's you know, a cool design and everything. But what we're going to be doing is making a little, this is not a perfect one, but a little thing kind of like that. So I don't want to like tell you exactly how it's going to all look, because it looks coolest when you open it up yourself and go, oh, look at that, it's kind of cool. All right, so to begin with, I want to discuss infinite like this. Imagine you had a piece of paper. Now, technically, ours is going to already be folded over, and it'll look like that. Don't fold it yet. I'll tell you what to do in a minute. We're just doing the math part of it right now. So imagine for a moment, if this is an 8.5 by 11 piece of paper, this is about 5 inches long, but I'd rather, it's actually like more than 5. I'd rather have it be 6 because then cutting it in half is going to be a lot easier. Okay, so let's say that's, if it's 8.5 by 11, and this is like 11, but I'm going to call it 10 because, again, my numbers will be easier to work with. If I cut out a piece this size and I go halfway in, if I just cut like that. Now, this is the important part. If you just cut like that, do you get that my piece of paper is not, no pieces are going to fall out of my piece of paper. It's all going to remain connected. So don't cut any chunks out. If you just cut like that, and then you folded right there, how much, once you fold it in on itself, you'll see when I show you in a moment, when you fold it in on itself, how big is that chunk that's missing? Is it half? No. What do you feel like it is? What's your gut? A third? A fourth? A fifth? Is your gut feeling that it's a fourth of it? A bunch of people saying fourth. All right, how about this? Let's do the math on it. How long would this dotted line be right there? How long is that? We do know. Because I said we were going to cut out half of that side. Half that way. And we're going to go, it's a quarter down and a quarter up. Do you get how that leaves? What's left was half of that side. Okay, so that side is 5 by, how long is this side right, hold on a second, right there. How long is that side? 3, because it's also going in halfway. And so then do you get that this area right here is 15? What would the area of the whole piece be? And 15 out of 60 is 1/4. Yes, so we took out 1/4. Then imagine for a moment that we did that again, and again, and again, and again, and again. Let me show you what it would kind of look like. So we'd take it down 1/4 of the way and up 1/4 of the way, and we would cut halfway to the fold. Like this distance would be all the way to the fold. That would be tragic. Your piece would fall apart. Now, don't do that. You cut it halfway in and halfway in. And now do you get that we've cut out not 1/4, we cut out 1/4 of what was left. So the first one was 1/4. The second one, how big of a piece did we cut out? Was it as big as 1/4? No. What do you feel like it is? 1/8? 1/16. You are correct. Now, just a second. Isn't that an infinite series? Couldn't we keep doing that? Then you'd need this formula. S sub infinity, but some kid's going to remember it. I'm going to give you a chance to show you remember it. Who's got it? A over what? Come on, you can do it. 1 minus r is correct. A over 1 minus r. If you knew that one, awesome. If you didn't, it's no big deal. You'd have it on the sheet. But now, use it and figure out what the answer is. Before we do the cutting, I want you to see that this is an infinite series, starting with cutting out a quarter, and then a 16th. The answer is not 4. The answer is not 3. What's the A? 1/4. 1 minus, what's the R? Well, how do you get from here to here? Think of it this way. 1/16 divided by 1/4, but it's kind of hard. How about, what did you multiply by to get from 1/4 to 1/16? 1/4. 1/4 times 1/4 makes 1/16. So that's 1/4. So that's really 1/4 over 3/4. Do you see why? It keeps coming up. That's the fraction over the fraction thing. You got to understand that. And I know you guys do by now. But when you first took the top 20, some of you had me in higher algebra, probably less than half the kids just had an automatic answer for that. Now you do. Just multiply by 4/3. Mr. Server, that's easy. And then notice the 4's will cancel, and what's the answer? 1/3. Do you get, we're going to end up cutting out 1/3 of the piece of paper when we're done. This plus this plus this plus this all the way down to the inside there. That's going to end up being, that blue area is about 1/3 of the piece of paper that we could see. Now I know it's really a folded piece of paper, but then if you open it all the way up, it might be still 1/3 of the total because the other part would be cut too. So anyway. Okay. So that's how this applies. One more like that, just to see a real test question, because on the test, do you think we're having you cut stuff out? No. But I want you to be able to actually do a real infinite question. Okay, so imagine for a moment that you start with 3, and it cuts in half, also known as 1 1/2. Cuts in half. I'm multiplying by 1/2. What just happened there? I multiplied by 1/2 each time. Would you please figure out what those would add up to? There's a formula for that. You should have it in your notes just one page back. Well, I guess on the test you'd have it sitting right in front of you, so I'll give it to you. Who's got it now? What do you say, ma'am? What do you put where? Okay. What's that? It equals 6. So times by 2/1, and that's 6. That infinite series adds up to 6. And again, if you really think about the concept of an infinite number of little tiny things adding up to a whole that's perfect and exact, it should freak out your mind a little bit. But it's the only reason you can get out the door. I'll use this example one last time. I am now 10 blocks. The blocks on my floor are about a foot each. Okay, if I'm 10 blocks from the door, do you get I would have to go 5 of those blocks to start going out the door? So that's halfway, and that's 5. Plus, now I'll have to go half of that. So how many more feet is that? 2.5. Now I've gone 7.5 feet total. Do you get, if I keep doing this infinite series, it will add up to something? It'll add up to 10. So yeah, it hurts your brain a little bit. It should anyway. That I'm going to keep going half of that, half of that, half of that, half of that, adding these teeny tiny micro parts, but we know that at the end, I'm going to get 10 feet to the door. So you can add them up. But what was the rule again? That R had to be something between Not negative 1 and 1. No. Between 0 and 1. Now, actually, though, there was a absolute value involved. So R could be a negative fraction also. We played with it in class and we were like, is this going to work or not going to work? And it turned out it did work. Do you remember talking about that? Okay. We said it was just between 0 and 1, but then we realized, ooh, negative ones actually also work. So I'll give you an example of a negative one. You start with 1 and you cut it in half, but you make it negative a half. And then you multiply negative a half again and you get positive 1/4. And can you add all of those up? Yeah, you can. So what's the A? 1. What's the over 1 minus, what's the R? Negative a half. So this would be 1 over 1 minus negative 1/2, which is really 1 plus a half, which is like 3 over 2. And that would add up to, flip it and multiply it, 2/3. That, the infinite series adds up to 2/3. So as long as R is between negative 1 and positive 1, R can even be 0, and it would work. So if I multiply by 0 each time, I can have a finite sum if I multiply by 0 each time? Pretty easy to tell what it adds up to. If I start with 6 and I multiply by 0 a whole bunch of times, what will it add up to? Okay. All right, so enough of that. Now let's actually do this paper folding thing. Now, for those that are at home and are not going to be able to do this, it's okay. It's just a visual representation of it. It's not something I'm going to have you make up. And your homework for tonight is to take last night's homework and go back and do all the problems that we skipped. That means we spent 2 nights on one homework assignment. That means that that's extra important. So I'd recommend having that done. So your homework is to finish last night's homework, the ones we skipped before, now go back and do. So get that all done. And that's all I have for the video for today.